Good morning and good afternoon to those of you in the East, and good day to those of you who are attending from different countries. Thank you for joining us today for the webinar, Keys to Successful Handwriting Recognition. My name is Don Du, and I will be facilitating this webinar. First, we're going to start with a short background, and then I'll introduce you to our speakers. As you may know, Parascript has been around since the mid-1990s. And it's one of the first companies to take on the difficult recognition challenge of cursive handwriting with a high degree of success, regularly getting well over 90% recognition in both check and postal address processing. The genesis of this webinar came from a customer we met at a conference a few months ago, who on introduction said, "You do ICR? We tried that and it was awful." That's a pretty fair point. So ICR in itself is both an art and a science. And our intention today is to introduce to you the art and the science and provide some background pointers to achieving high recognition rates. To do that, I'd like to introduce Greg Council, Parascript's Director of Product Management, and Shane Cooper, Parascript's Manager of Customer Support. During the webinar, we will all have lines on mute, though we encourage your questions. And if at any time you have a question, please submit it to us via the questions panel, and we'll try to take them at the end. Greg, over to you.
Thanks, Don. Going over to the agenda, there are a number of topics that we're going to cover today. First of which is just covering some common myths of ICR. Next, we'll talk about some differences, some key differences between OCR and ICR, and really why it matters. We'll cover some key factors involved with ICR success for your applications and deployment. We'll talk a little bit about successful applications using ICR, and then we'll walk through a quick demonstration focusing on how you can implement ICR specifically with our applications. So going and covering some of the myths of ICR, the first one is that a lot of folks out there in the industry would have you believe that all ICR is the same. And this would be from not only a technology point, but also the types of information that ICR can handle. Are we talking constrained handprint, unconstrained handprint, handwriting resembling cursive but not connected, or real cursive writing? There's just simply a lot to consider when addressing not only the type of information on a document, but also the format in which it is supplied. The second myth of ICR is that it just doesn't work well, and as Don said, there's a lot of that feeling out in the industry. Certainly there are many anecdotes of ICR uses that resulted in what we would consider less than stellar results. However, with the proper setup, ICR can be amazingly accurate. For instance, when applying ICR to financial deposit-based information, accuracy rates can be in the mid to upper 80% and even higher, while error rates are very low, say below 2%. So this is clearly a case of bad news spreading better than good news. Another myth of ICR is that it requires constraint. And by constraint, I mean boxes or combs or any other type of tool used to separate these letters. Essentially, that handprint or cursive have very strict controls for how a person writes the information in order to achieve positive results. While constraint is certainly ideal, it is not always practical, and even the best design forms cannot control user data completely. How well an ICR technology performs under a variety of situations, whether highly constrained or whether there's little constraint, really depends on the techniques used. Another common myth of ICR is that ICR includes cursive. Hopefully no one markets their ICR capabilities to include cursive. And while handprint and cursive are both the products of a human, the ability to successfully translate each into machine-readable output is based upon significant differences in technique and practice. So moving on to some key differences between OCR and ICR. There's certainly a lot of abbreviations in market speak when it comes to the variety of technologies commercially available to solve the image-to-data problem. OCR, ICR, ACR, NHR, there's just a lot of what I consider three-letter acronyms. Then there are the specific applications of these technologies that further complicate things. In here, you'll see abbreviations like CARLAR, MICR, and so on and so forth. So what are the major differences between OCR and ICR, and why is one set of technologies not always best suited for all problems? When we talk about OCR, we are really talking about converting data from an image that was created by a machine, whether it be a document created by an Office application such as Word or Excel, and even an old document that could be typewritten. In every case, though, the information is very high quality and very consistent. So OCR technologies were traditionally and historically built to compare the letter on the image to the letter within a database. If it's the same, then that's great. In this situation, letters like A can look like the letter A, with most of the time the only variant being the font in which that A is written. So most OCR technologies are sensitive to fonts. All OCR packages pretty much have a very large database of these letter variations due to fonts and other types of anomalies. And a few even have technologies that allow for the font to be factored out of the equation entirely. This is called omnifont. In most cases, OCR does not really require the assistances of third-party databases due to the quality and high standardization of the information. So to recognize the numbers in a typical Social Security number is no more difficult than to recognize the numbers describing the length of a 2x4 board. However, because many OCR technologies rely on matching a character to a pre-built database, the presence of noise, such as a comma or box, that could not be removed or ignored can impact the quality of the results. For instance, if a 3 is typed within a box that touches or crosses over that box, the technology, especially without context, would have difficulties arriving at the correct value. Now for ICR, pattern matching goes to a really different level. You cannot really have success deploying a solution requiring ICR without additional information to aid in the recognition process. Using that same Social Security number example, if that number is written in an open field, you most likely need to assist the recognition by providing the data type to look at or a pattern for it to match. So ICR needs more data to really be successful. Fortunately, this type of additional context can be easily supplied within the technology itself through the form of vocabularies or other business rules, or via customer-supplied data. ICR is also more sensitive to image and zone quality, since there is typically no standard reference to the characters or words as we would have in OCR. So next we'll talk about some keys to success with ICR. We're going to cover within this section image and zone quality, the ability for an engine to depart from image comparisons, as is typical with OCR, ability to apply multiple analysis of handwriting, the availability of context for your applications, effective testing and measurement of data quality. And what you're likely to hear from the market if you go to websites and start looking for information on ICR is there's really an emphasis on form design and that variations in user completion will impact quality, and this is the case. But if you keep track and implement these common keys to success, you'll have a better result in the end. So first for image and zone quality. Given these major differences between OCR, what are the factors and ICR? What are the factors for success when deploying ICR? First, the quality of the image or zone where the data is located is very important. If the technology cannot employ techniques to evaluate the data in association, and at the same time with the form structure, then accuracy will be severely hampered. Many times, solution providers will advise to make the form as clean as possible and to maximize white space between the form and the information, or use dropout forms so that information is the only thing left. But these requirements are very hard to enforce. Here are two examples of information, one in a constrained field and the other less so. In both cases, the ability to have high-quality data output relies on the ability to effectively remove the noise. Now for image comparisons and analysis. There are many ICR technologies on the market that evolved from OCR, as we've talked about previously. In this manner, many continue to use a character-based approach for evaluating handprint information. This works great for typed information, but how can character-based approaches evaluate a D from an A? More successful ICR technologies use a variety of techniques, including evaluating the nature of the character along with the word of which it is a part. So not only is the character being evaluated, but the recognition is aided by dictionaries or other context information at the word level to narrow down possible results. For example, many of you have probably received an email with the jumbled sentences as shown in this slide. While the actual content is not accurate, the research was never done at Cambridge, and the assertions on importance on placement of letters is not really accurate, the theme of humans looking at the entire word to recognize it instead of its constituent characters is accurate. Character-based OCR techniques would fall short if word-based analysis were not done. And as we will talk about later, if the word-level analysis is done post-recognition, data quality can be impaired. Our technology uses what we call XR elements, which are essentially the anatomies of handwritten letters. The letters, along with their larger words, are analyzed in order to produce high-quality results that do not depend on strict or close matches to a reference set of handwritten characters. Next, we'll talk about use of multiple comparison. It stands reasonable that if you have one answer from an expert, that answer could be right or it could be wrong. It's just hard to say with any accuracy, but add more experts and the results can be significantly improved. This is commonly referred to as voting, and many commercial solutions will actively promote or support using many different recognition engines to enhance results. The idea simply is that each engine brings a different strength, and the focus is on using specialized voting algorithms to arrive at the correct answer. However, difficulties can arise when the voting processes cannot fully take into consideration these different strengths and weaknesses and how they could affect the answers. So in reality, use of third-party voting also increases complexity and could actually have adverse effects on data quality. Most third-party voting will use what is called the waterfall approach. For example, if we take a sample of 10,000 images, the first system is able to read 60%, or 6,000 of those, of the set. Of the 40% or 4,000 images that are remaining, they are sent to image 2, and let's suppose 25% of those, or 1,000 images, are read. In total, we have 7,000 images that were finalized and able to be read. But a more refined and more complex voting scheme involves evaluating data from multiple engines during the recognition process. In this parallel architecture, using the same sample of 10,000 images, both recognition engines, let's suppose, are able to read 60% of the input stream. However, in most cases, these engines will not read all of the same 6,000 images, and combined, let's say, will be able to read a larger percentage of information, for example, 7,500. Also, because it incorporates voting technology, of the information that both engines recognize, the system will be able to select the answer with the highest confidence level and reduce the chances of accepting an incorrect answer, thus reducing error rates to a very low rate, say 1%. As a result, only 25% of the items must be keyed, and the overall accuracy levels are dramatically improved. Some key differences between this waterfall and parallel model are waterfall can improve overall rates, but in most cases, error rates tend to be higher. When you use parallel voting mechanisms, they compare results and confidence levels from all engines at the same time, which can offer greater potential to improve both read rates and lower error rates. And the degree of improvement for each is also greater. At the end of the day, what makes parallel voting work? Deep within the code rely on complex, sophisticated technology that includes statistical processing, neural networks, and context database information. So the ability for a solution provider to effectively create their own voting algorithms is really limited to the technical wherewithal of the staff that can implement it. As a result, this voting allows for statistical processing to make better decisions. And parallel voting allows you to affect the overall final system, and we can consider answers from individual engines to determine the best results. Now on to the importance of context. Context is typically referred to as a vocabulary or a custom data source that aids with recognition. ICR engines that state no context needed aren't really telling the entire story. All engines, even OCR, require context. Examples of context include data type, acceptable ranges of data, or data references themselves, for example, an address database. Many engines provide context built in, but always look to see if your applications can provide even more. Most engines allow specific tuning to add additional context where needed or desired. At the end of the day, the key to success is broad built-in support with the ability to easily add custom vocabularies, or context. Next is how the context is used, during recognition or after. For in-process use, Parascript calls this dynamic vocabulary. For example, in this example, the letter this example 1, this character might be the numeral 7, or it could be the cursive letter T. How do we know? Well, through the use of context information, such as identifying whether the field type is alpha or numeric, the recognition engine can discern which one it is. Context information can be as specific as a range of numbers, dates, or values, or as broad as field type. Proper use of context information helps determine the correct result with a greater amount of accuracy. For this next example, is this a valid date? We just don't know. In this case, this date is extracted from a form field, and the ages of a dependent child is defined under age 21. On the form, if the child is over 21, then the field is left blank. Because of this context information, it is clear that the date in the image is actually August the 2nd, 1990, even though the digit 9 looks more like a 4. In this last example, it's not really clear if the first symbol is a D or a combination of a C and an L. Recognition without vocabularies would not produce a reliable result. Use of a static vocabulary approach would require that both hypotheses are produced and stored until the end of the recognition process, when validation based upon the lookup table takes place. In that the ambiguity is in the first symbol of the word, it also follows that if the word were longer, there would be more hypotheses. These hypotheses would need to be stored and analyzed. The result would be slow and potentially yield lower recognition accuracy. But using dynamic vocabularies, there is no necessity to analyze and store all possible hypotheses of segmentation. If the dynamic vocabulary does not contain a combination of C and L at the beginning of the word, the only possible segmentation solution is D. Clearly, dynamic vocabularies have the ability to produce higher recognition accuracy. Next is effective testing and measurement. In a recent Document Imaging Report article, industry veteran Brad Paxton made the assertion that most end users of OCR or ICR don't know the quality of their data. He even stated that he believes that many users don't even seem to care very much. To quote him, there are an astonishingly high number of uninformed OCR users out there. So if that's true for OCR, what must it be like for the ICR-based applications? In reality, the ability to know the quality of data output is very reliant on the tools and capabilities of the technology with this regard. From a process and procedure standpoint, sample production data should always be routinely tested to ensure accepted recognition answers are not actually errors and vice versa. But the technology should also allow for simple and controllable, what I call knobs, to allow for testing output against acceptable error thresholds, and provide support for efficient identification of errors and enable those errors to be easily corrected. Unless you know the quality of your data before going into production, and at checkpoints post-production, you're left exposed. At the end of all of this is really understanding the applications that are best suited to ICR processing. Some rules of thumb are applications that can make use of pre-built context, such as addresses, are a great fit for ICR. If you have applications that have strict adherence to the types of data involved, such as those with check processing, ICR is a very, very capable technology. ICR can also be used for applications that are based upon context in the first place, such as keyword searching. In this instance, the keyword is the context, so it is easier to identify matches with high confidence. And of course, form-based data entry, where the fields themselves provide data entry control and context. A last consideration is to understand applications that have mixed data. One reason this is important is that oftentimes we have found forms use a combination of machine print, handprint, and cursive handwriting. If, for example, we look at this Department of Motor Vehicles form from New York, we will see all three types of handwriting styles on just this one form. The ability to successfully handle this type of form depends on the technical capabilities of the technology or the technical wherewithal of the team implementing the solution. You could use 3 different types of recognition engines or select a single engine that can support all 3 data types. To wrap things up, there are several important considerations to ensure that your data capture recognition system offers the latest techniques. If you have information that runs across machine print and handwriting, if so, do you want to combine multiple engines or select a single vendor? The decision will not only impact the complexity of the solution, but also the data quality. Does the technology have reliable abilities to remove the noise from a document prior to and during recognition, or does it rely on highly standardized templates? Does it use context, either built-in or user-specific, at all stages of recognition, or is the context just used to validate the results? Does it employ multiple discrete engines to provide high-quality output, or does it support a waterfall voting style of integration with third-party engines? Can you easily test output data and see the effects of adjustments quickly and easily, or do you have to wait until your system goes into production to see what those results are? And lastly, does the technology process information as a black box, or does it allow the user to further constrain the acceptable information output? Next, I'll hand it over to Shane, where we're going to show you a demonstration of some of these techniques, specifically applied to ICR.
Hello everyone, my name is Shane Cooper. I'm Customer Support Manager here, and as soon as Don hands me over the screen, I am going to demonstrate our preparatory tool that comes with our FormXtra product line. We have a variety of FormXtra variants, from SDK to an enterprise, and included with our check product. So what I'm going to show today is the Form Definition Studio aspect. This is what we use to prepare a particular workflow in reference to an ICR set of strategies that Greg has so eloquently laid out. So like with most cooking shows, I'm actually going to bring the cake out of the oven and show it right off. I'm not going to go in and show you all the ingredients. So what I'm going to do is point out all the elements that speak to the various strategies that Greg mentioned using my nicely baked cake here. So what I've done is I've already set up a base template. This is a very simplistic membership form. This is a fairly blank document. We've got a variety of workflow tools. This is my test deck. It's a set of samples from our production environment that I can visually see how it applies to the various elements and the field properties I'm going to be setting up. This speaks to the effective testing and getting dynamic feedback immediately while I'm preparing the form definition. So I've got a fair amount of fields on this particular one. I've got first name, last name. I've got a duplicate first name, last name that is a voting field which speaks to the parallel strategy where we can recognize multiple areas on a form and interrogate each of the results based on context, no context, different handwriting mechanisms, and or other elements on the page, and basically compare those results and then determine the best of those results for the output and or the business strategy for doing the data repair or the keying repair for those areas where it falls below the threshold of our acceptance level. So speaking to each of those fields, I can take a look at where they are on the page. I see the first name and last name, and you'll see that the sample area jumps around, so I can actually see where that lands on the page. I've got a membership identifier that this particular membership form requires a uniqueness. We have an address block and a phone number. So I'm going to start with a very basic field, first name. And I'm going to take a look at the actual custom elements about that first name and point out a couple of very interesting aspects with regard to this particular tool and getting dynamic feedback. The first thing I can do is set some parameters for image cleanup around this particular field. I see a sample of the field where it resides on the form. I can determine that there's a fairly blank area here, but to speak to the image cleanup area, I've actually got pre-printed text removal turned on. And what that does is speaking to the combs and lines and various elements that are on the base of the of the document, I actually can ignore, or this field set will actually ignore all those base elements and focus strictly on what I want to read and get good results based upon those set of settings. So everything that's in a cyan, this is a sample of, these are actually dynamic results coming directly from the sample test deck. I'm actually reading these letters using various settings. I've selected the first name field type. We have a language type and the writing style. And you'll notice that all the elements that are consistent on the form are in a cyan color. So my engine is actually ignoring the cyan elements. If there was a line or a box or a comb, those same areas would be dropped out. This cuts down on the noise level and cuts down on the ancillary areas for our linguistics engine to determine what the actual values of this particular field are. Now this particular field is a first name. It's actually a very specific field type that that comes with the product. It's very standard. We have a number of those that are discrete and known based upon our experience. We have alphas and numerics and checkboxes and age and address, barcodes, and a variety of different standard form areas and field areas that we found to be very effective through the years. In this case, I've chose first name because behind that field is an actual first name vocabulary for context. We have incorporated the United States Census data from the last set of results, and that is our first name database. We have a female first name database, we have a male first name database, and we also have a last name database. And it pretty much ranges 5,000 to 6,000 variable names and the different spellings. So based upon that context, as we read the elements such as Laura or Diana or Joyce or Wayne or Peter, we can actually compare what we're seeing, each letter, and not only the letter, but as the one slide Greg had, where the sentence was a little jumbled up. Again, we're going to look at the context of the name compared against the database and provide the highest results. In these particular samples, I've got the actual results showing up underneath the sample snippet of SAM and the value of 100. This is a high confidence level based upon those intelligent character recognition variables and the context of the first name. Within the tool, I can move the field space around and fine-tune this area. It's all dynamically happening as I move the field. You'll actually notice that we're rerunning the engines dynamically to validate what kind of results we're going to get from this particular space. And this is very key for preparing a workflow. Now as the technician getting this ready, I have a super high confidence that I'm going to get very good results off of the way I'm presenting this field and the way I am setting variables and specific properties on this field. If there were lines, I could remove horizontal lines, I could remove vertical lines. We've got a noise removal capability, combs, and then a variety of alignments to a field, to a line. As the characters are being read above a line, we want to align to that field text. So a lot of options here at the field level. So this is the first name field. Now looking at the last name field, the exact same context, but in this case I purposefully chose a different field type to speak to the constrained handprint both with and without context. The first name field has that built in. That is just a known vocabulary assigned to that field. This particular one I chose to be alpha, as I expect all the letters to be alpha letters. I could choose alpha and numeric if for some reason there were some numerical values expected to coincide with this particular field. In this case, I actually have chosen a custom vocabulary. And you'll notice in this line, vocabulary 1, I've got a database by the name of last. This is actually a duplicate of our last name database, but I'm using it for demonstration purposes from a customization. And where this is very key is when you're using non-American names. We've done a number of projects in India, Malaysia, Germany, France, and other international locations. And so those areas have very specific naming databases. Pierre is named very different. Pierre and Peter are two very different names in the French-speaking. We have Indian names that are very unique to that region. So you can build those vocabularies specific to that region and that area. Again, in this case, I have last. So what I've just showed are the custom vocabularies that we can create on the fly or through an importation process. In this case, I happen to have a Hispanic first and last that I can access. And these databases are actually built in specific to this form definition. However, speaking to multiple context options, we can build it. We can take and look at an existing database through a database string, through an OLE string, supporting any of the major database technologies that exist in the world, SQL-based, access-based, etc. This particular example is, or last names that are here within our vocabulary that's built into this particular form definition. But I could actually create a new vocabulary or a new database vocabulary. The new database vocabulary gives me the option to put the string in, put the table in the column. If I have a known database, I can select from those areas or those particular technologies, put the discrete information, username, passwords, and then select the database columns and tables where I want to take a look at that data. So that's a very flexible mechanism for our vocabulary context for a variety of different fields. And that's why I wanted to show this. We have in our alphanumeric and a variety of other field types, we have multiple vocabularies that we can tie together and string together to give the highest accuracy rate for the export for the data export. So those are two interesting field types, first name, last name. I'm going to speak to, I've got a duplicate of my alpha field. And this is actually a separate engine with no context. I have 0 vocabularies. This is just our engine, linguistics engine, reading the values that it perceives. And again, it's in this particular case, it's not great. I have no image cleanup assigned. I could do some image cleanup here. We go ahead and turn these things on, do some noise removal, and get some better accuracy out of that. But again, the main thing is I can now, and you saw when I just selected from no pre-printed text and no noise removal, I immediately started getting much higher recognition capability. So that speaks again to the noise removal aspect. Now this particular field is a voting field. It sits on top of the corresponding first name field, and our engine can read each one of them separately, get different results, and then we can compare those results in a parallel fashion through business rules, through some decision trees, and determine which of the better of the two engines gave us the best results. I could change a variety of things from different writing styles, such as I want to just look at cursive. I anticipate some cursive in this field, so let's just go and compare cursive against everything else. Handprint, constraint handprint, machine print, or auto detect. If we're not totally sure what's going to be in this particular field area, auto detect gives you the ability to gives our engine to automatically determine which of the typed handwriting styles are going to be most effective. So we have some other fields here. Member ID. This is a numeric, again, specific context. I do not expect any alpha characters to be in this. These are all numerics. It is machine print. It's a sticker. It's a known quantity. And we can validate its length. We actually have the ability to determine that we know that this numerical value of this sticker is always 10 characters or 10 numbers. So we're going to set a very specific length. If it was a social security number or a phone number, We could set those templates. I do have a phone number here. Let's take a look at that really quick. And you'll see the same. I've got a phone format that can determine how that looks on the page, whether it's got parentheses around it, or hyphens, or no hyphens, or periods, or dots. You can create a variety of different formats to address those specific areas. Last, we have address fields. This is a very unique aspect to our engine in that we have a fairly large address database sitting behind this field set and all the different blocks that I've defined on this page. In this case, I actually have this as one single field, but with multiple elements. In our address scheme, we can determine a variety of different block types. Actually, I have to create a brand new field. I actually want to show this. It's a very powerful aspect to the address scheming. I can actually say, I anticipate this to be one block. I don't know where the elements are. I don't know where zip and city and state are going to be. So look everywhere in this block for those discrete aspects. I'm only wanting to do street with a city-state zip combination, a variety of different combinations. In this particular case, I wanted each element individual for both recognition purposes and for data extraction purposes. So going back to the detail, the customization piece, you see, again, back to our test deck, I have a series of addresses that are dynamically being read and validated against our database. And the way this works is, regardless of where these elements are on the page, we're going to tighten up the view. So the view of the city, street, and zip in this area are compact to show these are the results from this form. These could be on various lines, various blocks, various aspects, but we're going to combine them here and show you what the results are. The way this works is we start with a zip. That is the most important area of an address block. So our engine validates the zip code being 43202, and it includes the zip plus, what is it, 5? Zip plus 4, zip plus 5? 4, thank you. I have people in the room giving me prompts. So zip plus 4. So we actually have the entire zip code portion in the database. From the zip code, then we can ascertain that is what state that's in, and then more specifically what city. And then even within that zip code region, we know all the streets and the address blocks that are in that area. So again, using that very narrowed information, we can read what's on the form, and using that contextually get as high accuracy as possible because it is very specific to an address scheme. So that's addresses, and pretty much the roundabout version of the demonstration. As I mentioned, we've pretty much hit the high points for the various strategies that Greg was speaking to in regards to constrained constrained blocks with context, address fields, being able to get dynamic results back immediately, getting feedback back immediately, being able to set thresholds and acceptance rates, and understand within just a few minutes exactly what kind of results I'm going to get in my workflow. So I believe at this point I'm handing it back over to Don, and thanks for your time.
Yeah, I would be remiss in really wanting to talk and finish this up without talking about cursive, because that's really our claim to fame. Cursive really provides the engine and the uniqueness around how we not only handle those types of human-created information, but also significantly aids in our ability to process hand print, whether it's constrained or unconstrained. So really, our software is learning software. Software really has a great capacity to use information and then learn from that information as it gets more and more data. Let me take let's look at a couple of examples. In the first one, just as we make adjustments with our eyes to distinguish between characters, we can help recognition software do the same through certain contexts or rules. We can certainly add distinct lines or combs to define the breaks for them. We can add databases or business rules, such as identifying this field as a type of lens color. This will also help software determine the correct answer with a high level of confidence. When we get to forms and types of information that don't have clear distinction, as in sample 2, what would a typical character-based recognition system list as the first character? Is that an A? Is it an O? Is it a C? Field-based or word-level recognition that has its heritage in cursive analysis would not only look at the whole word, but also the phrase or field context. With confidence, we can list the answer as Bay City, even without the constraint that is typically mentioned on form design. And finally, knowing whether this field is alpha or numeric, or a combination, will help us decide the answer. So additional context information that's built in to the technology can help improve confidence and the level of accuracy. So software can learn, and it can use both built-in context and technologies that engines provide. And it also can substantially learn from the additional information that it can extract during the recognition process, as well as the information that is supplied directly within the application.
Greg and Shane, thank you very much. For the next few moments here, I'd like to address any questions that have come in throughout the course of the presentation. I have a handful. The first one here is probably best for you, Greg. In terms of the best practices that you listed earlier in the presentation, which ones do you consider to be the most important to achieving a high level of recognition?
Yeah, this goes back to slide 9 on the keys to success, where we talk about image and quality, the types of technologies used, the ability to do a number of different types of analysis, as well as context testing and whatnot. In practice, really, first you want to choose the technology that fits the application. That is a foregone conclusion. If you don't source the right technology as it applies to the application, you're going to lose from the very beginning. But after that, it's really understanding the context available for the application to succeed. A lot of engines, as we mentioned, contain that information built in, but you also want to be able to aid in that through any type of additional information, either arguably during the recognition process. But just as important as we stress with some of these keys to success are the ability to test and easily test and tune your output. So you do that before the production implementation, and you really understand how well your system performs. Unfortunately, a lot of the technologies out there don't really enable you to do that, at least in an easy way. So you're going to want to look, as you start getting demonstrations and evaluating technologies, that you want to emphasize that piece of it.
Next one, Shane, I think this may be for you, is are the names of the databases, or the databases of the names and the vocabularies included in the SDK or the enterprise product?
That's a real simple one. The answer is yes. It's on the name vocabularies, as well as the address database come with both products.
The address database would be the U.S. address database.
U.S. address only. That is correct.
And then I have the last question is read rates. What read rates are achievable realistically using ICR?
Realistically, the read rates are really dependent on the application and the information available. We talked about financial documents processing, specifically around checks and remittances. In these cases, it doesn't matter if it's ICR or even cursive. We have real implementations where we are getting, or where the customers are realizing read rates in excess of 90%. It's never going to be to the point of machine print, just simply because you have so many variations. But applying the technologies and being able to analyze not only at a character level, but more importantly at a word level, and understanding where these breaks are, and also the ability to know that a name is a name field is a name, a number a field, or for instance the courtesy amount, the box that you put the number in, is a number, significantly aids us. So I will say the application and then the available context. For addresses, address processing can actually achieve with a very, very accurate address database in the high 90s. In fact, very high 90s, so really approaching that of machine print. So really, again, it depends on the application and the available context, but successful ICR is in production all over the world.
We had another one come in. Is there any way we could see the output of the digitized data?
Yep. I like to answer these. These are really easy. We certainly can. Don's going to hand me over the screen again, and I will show you an output from that sample, and I can speak to that. Really good question, actually. We have what's called a release function. We release in a variety of different formats. Be XML, can be get this little thing out of the way. Get that down. Finish processing. We can do fixed width, fixed separation, XML, or database. Same technology or capabilities as with vocabularies. I can reach out and put this data into a staging table, directly into production workflow on a database level, whatever those needs are, XML or text separated. The three most common in our world are XML, database, and text separated. Those are probably the most common. I can determine a variety of different columns from this set of data. You may notice I do not have my voting fields in here. Those are specifically to the business function or to the business decision part. And I can actually pick parts of the field that are from the address area. Actually, let me get down to the document, pick the address. In this case, I've actually the output is the entire address block, but for whatever reason, let's say we just want to do a specific section, I can select which part of the block I want it exported. I can also increase a column, add another field, and pull a piece of that field out, and then I can dynamically see my results by simply building the record results and output. And at this point, I could actually save the output file as a XML or a text file, and immediately pull that into a spreadsheet and get an immediate idea of what my results are going to look like. And I hope that answered the question in a real quick fashion.
Okay. Okay, well, if that is all, it appears that it is, we really appreciate your time. We hope that you found this to be an informative session. A replay of the webinar will be made available, and we'll send you an email when that does happen. In the meantime, if there's any other questions, feel free to contact us. Greg and Shane are available directly, and you can also email info@parascript.com. Thank you very much, and have a nice day.